Hi guys, I want to walk you through an example using a DC motor. So this is different from a servo motor, although it still uses PWM signals to control the motor. It doesn't work in really the same way at all. So I want to go through that process and explain it to you. Um, First of all, let's look at this code. I'm defining, this is for the Artemis Nano. Obviously, it's an Arduino program. Um, And so I'm defining 4 output pins on the Artemis Nano that control the motor. AN1 and AN2 control the direction of the motor. PWMA controls the speed of the motor. And standby is a pin that can either enable or disable the motor controller completely. So when standby is high, the motor controller is enabled. When standby goes low, then nothing on these pins makes any difference. The thing doesn't do anything. But these all need to be set up as outputs. So you can see the first thing I do in the program is define them all as outputs. And then I just set standby high because I want the thing to work. So I'm just going to leave it high. In this project, I could have just tied standby directly to power, since all I do is set it high and then leave it there. But there may be times when you want to disable the motor for a period of time. If you're not using it, it saves a lot of power if the chip doesn't have to run and do anything. So let's go ahead and look at the actual breakout board we're using is the so-called SparkFun motor driver with headers. So I bought it with headers already soldered on to save me a little bit of time. But basically, we have a bunch of these in the lab that you can use. You can just put them right into your breadboard and connect them. What I would like to do is I've also posted to ACE under Resources the data sheet for that guy. And so I've got it pulled up here, and you can see the control layout of that chip. There are 2 motor controllers really in this one device, so you can control 2 motors at the same time. This is useful if you want to make a robot that has like 2 wheels controlled by separate motors. If you make one turn and the other not turn, then you can turn the device. You can make both go forward to go forward, both go back to go back. You can even have one go forward and one go back to have it turn in place. So a little robot with 2 motors, this is a convenient controller to use. Notice that we've got the PWM, AN2, AN1 are right there. Notice also that it's got VCC, which is a logic power supply. In this case, we'll be using the power from the Artemis Nano to deliver that. It'll be 3.3 volts. But because DC motors require a lot of current, you can't power the motor with the same power supply that's being used to power the microcontroller. So there's a separate power supply for that. I have a pack of batteries here that I'm using, but you guys can use the DC bench supply right there at your bench. You can probably turn it up to 6 or 10 volts, and that'll be fine. I happen to have 4 1.5 volt AA batteries, AA cells, which gives me around 6 volts. And then, of course, you got to have ground. So that's the way that thing works. Now, the motor actually connects to pin A1 and pin A2, and when AN is high, the current flows from A1 to A2. When pin A2 is high, it flows from A2 to A1. If they're both high, then it's a hard break. In other words, it forces the motor to stop immediately. Whereas if they both go low, the motor can just coast. So what I'm doing in my program, I'll point out, I'm taking care never to set them both high at the same time, and we'll see that here in a minute. Let's go ahead and look at the code. So I define those 4 pins. I set them all as outputs because they all have to be outputs in order for the Artemis Nano to control the voltage on those pins. And then I just wired them right up to the motor controller. And I have 2 functions here, set direction and go. So set direction, as you might guess, it sets the direction. So it's going to set pin 1, A in 1 to high and A in 2 to low to go forward. It'll set A in 1 low and A in 2 high to go in reverse. And then the PWM pin, it needs a PWM signal with a duty cycle proportional to the speed of the motor. So if the duty cycle is 100%, you get full speed ahead. If it's 0%, you get 0 speed, and anywhere in between you get some kind of intermediate speed. So you can see the way this works. You pass in a direction, either +1 to go forward or -1 to go backward. And I'm taking care to send them both low to begin with because I never want to have them both high at the same time. If you set one high and then set one low, there's a danger that they could both be high at the same time if you're not careful. So anyway, this is just a nice safe way to make sure they're both low to begin with. And then I either set pin 1 or pin 2 high depending on the sign of that direction value. To set the speed, what I do is I take a number between -255 and +255. I use that in analogWrite, the magnitude of that value, to set the PWM signal. Remember, the way analogWrite works, you get a number between 0 and 255. If you send in a 0, you get 0% duty cycle. You send in 255, you get 100% duty cycle. And anything in between, you get a duty cycle in between those two limits. So I'm taking the magnitude of the speed, the absolute value of the speed, in order to determine the PWM signal, and I take the sign of the speed, either greater than 0 or not, to set the direction. And then if speed value is positive, I set direction to +1, and I set the analogWrite to the magnitude of the speed. Otherwise, I set direction to -1 and set analogWrite again to the magnitude of the speed. Because the PWM duty cycle determines the speed, whether you're going forward or backward. And the last thing I want to point out is I do a C hack here. Basically, I'm using the C syntax to do an inline check. I'm trying to remember. Anyway, the way this thing works is if mag speed is greater than 255, it sets it to 255. Otherwise, it just keeps it the same. So there you go. So that sets mag speed to be capped at 255. And then the loop is actually quite simple. I just set I to -255. Then I call the go function to set the speed and the direction. It starts in reverse, full speed, and then every time through this loop it increments I by 1. It waits for 1/10 of a second and calls the go function with that speed. So it's going to go from full reverse through 0 to full forward. Then it's going to stop. Here it stops for half a second, and then it just starts the loop up again. So let's see how that works. So here I have the oscilloscope running. I've got the top trace is the direction pin, and the bottom trace is the PWM signal. You'll notice that the duty cycle is getting smaller and smaller and smaller. It's going to go through 0, then the direction's going to change, and then it's going to get bigger and bigger and bigger. I should say this is pin A in 1 that we're looking at. So when it's positive, the direction is forward. When it's 0, that means we're going backward, because then if I looked at pin 2, it would be positive. But I only have 2 traces on my scope, so I had to pick one, so I just picked pin 1. Now this is going to get up to plus 100% duty cycle, then it's going to go to 0 for half a second, and then it starts out full reverse. So the direction pin went low, and and then now the duty cycle is getting smaller and smaller and smaller again. Okay, let's see how that works with the motor. So let me go ahead and set that. Okay, so here I've got the scope, and you can see I've hooked a wheel up to this motor. So what I'm going to do is I'm going to wait for the duty cycle to get close to 0, and then I'll plug in the power of the motor here. And it should start with no speed, which means it won't be moving. But then it will go forward, and then it should reverse, full speed reverse, and then slowly get closer to 0, and so on. So here it is. That's pretty close to 0. I'm going to go ahead and plug it in. And there it goes. Now it's going, that's my forward direction. It's going to go faster and faster as the duty cycle increases. Okay. And then it'll reach maximum speed as the duty cycle gets closer to 100%. Okay. Then it's going to stop for a second, boom, and then it goes backwards, full speed backwards. It's going to slow down slowly. It's 1/10 of a second, so it takes about 25 seconds to go to get to 0. Slowing down. Duty cycles approaching 0. Now it's 0. It's going to start going forward now. The direction pin went the other way, and there it goes. So you can see it's speeding up again, and it just repeats forever. Okay, so let me go ahead and disconnect the power. You get the idea, and that's the way it works. So anyway, I hope that helps. That's how you can control a DC motor. We've got numerous motors that you can use. We've got a lot of those DC motor controller guys. So I even have some, for your final projects, if people are interested, I have some robot chassis that we can use to build little robots if you want to. I've got some big robot chassis. You could build big robots. So if you like robots, that would be an interesting option. But of course, anything you can think of to do with the motor is fair game. So, and don't forget, you can also use servo motors. You can also use stepper motors, which I'll explain. Servo motors we already studied in the Lab 7. Stepper motors I'll explain in a separate video. All right, I'll see you guys soon.